Afternoon. Assalamualaikum everyone. So we will start our class continuing from the previous lecture. Last class we stopped at this exercise, correct? For those who are absent last class, make sure you watch the recorded session. Okay, I already upload in CN. It is better to use black background or white background. Can you find out this one from the previous lecture? Last class we discussed on the bisection. Okay, bisection, we need to find out the XR. Okay, using the equation. Okay, using the equation from bisection, this example we get the XR is 15.9 something. Okay, with the stopping criterion is 1.96. Okay, last class we discussed that how to decide your XR and whether your XR is the next XU or XL. We have the what from the slide over here. Okay, we have this. If your FXL, FXR negative, so XU is, your XR is the new XU. Okay, using this negative XR is XU, positive XR is XL. Okay, now another method to decide your XR, whether XU or XL, apart from using that one, you can also use this method where you see your FXR. Okay, this is our focus point. Okay, this is our focus point, FXR. Once you calculated the FXR, here it brings positive charge for the first iteration. Okay, first iteration, FXR positive charge. Last time we checked FXR multiplied by FX what? FXL, right? FXL. FXR multiplied by FXL is negative, so the XR will be the next XU or XL. Negative will be XU. Okay, negative. If positive will be XL. Okay, that is one from the slide. Now, another method is the easiest one. You see the FXR positive. Positive. Okay, so for the next iteration, this positive value will replace the positive value, either from FXL or FXU. Okay, I repeat. FXR calculated for the first iteration brings positive charge. So for the next iteration, in order to decide whether XR is XU or XL, we check for the FXR value. This is positive. So this positive will replace the previous positive value. The first iteration, this is positive. So for the second iteration, it will replace this value. That's why here you have the positive value. This is from the FXR. Okay? Get it, the point. Positive replace the positive value. for the second iteration. If it is negative, okay, you see for the second iteration, the new FXR is negative. Then it replaces the negative value, which is XU. Okay, here negative. Previously it is negative. Now it replaces the value. So this one is the one being changed. Since FXU being changed, so the FXR falls under FXU. Then the rest remain. Calculate the new FXR. Then the new the new XR, then the new FXR. The new FXR negative, so replace the negative value from the previous one. Here, it comes to here. So it falls under FXU, so the XR will go to XU. The next one is positive. So positive replace the positive value. So here it will go to FXL. It replaces the FXL value. So FXL. So the XR calculated over here will go to XL. Okay, it's up to you which method to use. Okay, we try to do this exercise again. Last time we did for the A, graphical. Okay, for graphical. Now we try to do for the bisection. Okay, bisection. We focus on the B. Yeah? Okay, we do for the B. Question asks you to find the H using by method with stopping criterion of 5%. Okay, ES is equals to 5%. First thing, rearrange the equation. Okay, this part we had done in previous class. You must get until fx equals to 0. Okay, 0 the fx side, the y side. Because xr is when y equals to 0. Okay, once you get this equation, then we proceed with the iteration. In question B, okay, so sorry, the XL given 0, XU given 2. Okay, the bracket, the range. So now, start your iteration using bisection. So your iteration, what else that you need? XL, XU, FXL, FXU, then XR, FXR, then the EA in percent. Okay, the first iteration, you should start with what? XL 0, right? So 0. XU 2, the given range. So FXL, find out FXL and FXU. Using this equation. Okay, those who absent in the class, do you know how to get the tan H? The mode over there is tan H. Do you know how to use it? Your calculator is only tan. Hyperbolic tan. XR using the bisection equation. Bisection. So you get XR as 1. Then find the FXR. What I get for FXL? -4. FXU? 1.9787. Get the same. FXR? All get the same? Okay, now to decide whether XR to be the next XU or XL. From the latest method that I mentioned, here FXR is negative. So this negative value will replace the negative value. So here, previously, FXR is negative, right? So for the second iteration, FXR will fall under FXL. So since it's fall under FXL, so XR will be XL. Cannot get it. The first iteration, FXR is negative. Okay. So for the next iteration, this negative value will replace the previous negative. That means it falls under FXL. Okay, put in FXL. So FXL, XL, right? So the XR is XL. Okay. Now the rest remain. XU still remain at 2. FXU remain. Now find the new XR between 1 and 2 using the bisection equation. XU plus XL divided by 2. Okay. Sorry? 1.5. Then find the new FXR. Positive or negative? Positive. 1 point. The rest get the same. FXR 1.0218. Positive, right? Okay, so that FXR is positive. So for the third iteration, it will replace FXL or FXU. XU, because XU is positive. Okay, so it replaces FXU. So your XR, the 1.5 here, will be the new XU. Okay, before that, calculate the EA. The EA here is for the XR. What is the EA? The first one is not applicable. Second one, okay? Yes, 33.3. Question 1 until below than 5. So you have to proceed until you get EA below than 5. Repeat the same step. Okay, proceed with your calculation until your EA below 5. So your answer for bisection should not deviate too much from answer A. One and adjustment. The XR just now you get what? 1.03. EA? 3.03. Okay, so you should be getting around this figure. Until how many iteration? 6 iteration. Because later on we will proceed with the false positions. Similar method but different equation of XR. Once you get the XR value, compare with the graphical that we calculated last time, that you plotted it down. So the XR value from last time we did around 1.1 to 1.2. So this bisection you get 1 point something. So it's still in the range. If you get, let's say the bisection, you get, for example, you get 5, then your answer is wrong. Because answers from A and B should be in the range. It just use different method. Okay, can I proceed? I proceed first, take your time later on to understand. Okay, I proceed to a false position method before we do the exercises, because most of the question will ask you to compare those methods. This one later on we do. Okay, in false position, last time, just to refresh, if bisection, it will half from XL to XU, then it will half until it approach the XR, the Y equals to 0. Okay, in false position, for example, the assumption is this is the XR, XL, XU. Okay, the assumption for false position is the gradient for XU to XR and XL to XR is the same. Okay, F XU minus fxr is similar to this side. Okay, this is gradient 1, gradient 2. So the assumption is this fxl minus fxr okay, the assumption is this gradient 1 similar to 2. Okay, that is the assumption for false position. Now for false position, you will use this XR value, XR equation. This is the equation. Last time in bisection, the equation is simpler. XU plus XL over 2. This is bisection. Okay, now this is false position equation. Similar step as bisection iteration, but to find out the XR, you will use this equation. Okay, or there is another equation from the derivation of the assumption. Okay, I give you one example where let's say we have no need to copy, later you find out. Follow me closely because this one is on how to get the equation. Okay, let's say we have this function XR. Here is the XR. So from the assumption gradient, this gradient 1 is equivalent to gradient 2. Is it too small? Okay, I try to make it bigger later. Now gradient 1 equivalent to gradient 2. We know that the gradient 1 here is fx. This is x. Okay, so gradient 1 here make it 2 because I follow my example. Okay, fxl, fr over okay, this one is the equation to find out the slope, the gradient, right? So this is gradient 1 equals to gradient 2. Now from here, we need to find out the XR equation. Okay, the XR. So multiply both sides. From here, you will get okay, equal to the other side. Multiply, okay, this side, multiply this. Okay, so we move and we rearrange the equation. Now from here, fxr is 0. Right, fxr is 0. So we cancel out those fxr, 0. Now from here, you will get Okay, by rearranging this until you get the XR equation, which is okay, this is the final equation. This one I show you how they derive from the assumption to get the final XR equation. Okay, so basically this XR and with the equation from the slide over here is similar. It's just the rearrangement. Okay, if this one you get the same denominator, then rearrange, you will still get this equation. Okay, so in midterm test or final exam, you can use either directly use this equation or this equation. This equation will be given, no worries. Okay, will be given, no need to memorize. But you should know which one is false position equation, which one is bisection equation, because both are to determine the XR. Okay. Now, similar concept as the the bisection. Okay, now we try to do the same equation, the same exercise just now. The same exercise. Okay, here, this same exercise, but using false position. Using false position method. Stopping criterion is still 5%. Wait, I put in the new slide. Okay. Using the same equation as in here. Okay, you can use this same equation, but to find using bisection. So the bisection one, your XR, the equation would be Okay, similar step, do the iteration, then the XL, XU, FXL, FXU, XR, FXR, EA. The difference is the equation to calculate the XR only. The rest similar to bisection. So your final answer, are you sure in the same class?
Yeah, that's same. Sorry, Mr. Davis. We wasn't there missing. How would you answer?
Okay. So your XR, you should be getting similar to bisection. One something, 1 point something. Yes. New chapter. You should watch the previous lecture first. Then only you can understand this. The XR equation, we can use this or either the one in the slide. Both will get the same. Okay, for FP, for false position, your XR is this one, 1.067, around this figure, and only required 4 iterations. Second XR, you want Okay, try to proceed and make sure you get the answer, the correct answer. You must try to do it. Okay, you cannot just watch and understand. This is maths calculation. You have to try. For those who miss out the previous class, watch the recorded session first. Then only you can understand today's session. Okay, now I will conclude for the bracket method. So for bracket method, we have the graphical, the bisection. Okay, the graphical, the one that we need to plot the graph. Graphical, plot the graph. Okay, this one you will need the graph paper. Bisection, the XR calculation using this equation. Bisection, no plotting graph, only calculation. Okay, using the XR equation. But for false position, also calculation, but different XR equation. Okay. As previous slide, which is okay, this is for false position method equation to find the XR. So all of this is bracket method. Bracket method means you have the XL value and XU value given. You must have the range. Within what range? If the question doesn't give you the range, ask for it. Okay, if not, you cannot proceed with the calculation. Okay, that one is for bracket method. Next class, I will proceed to open method, which is different method. Okay, open method. So far, any question for this bracket method? Okay, for you to understand more, you try to do in the whiteboard in the Teams. Okay, I put the question here in whiteboard Teams. Those who please request through the link I put in CN. Okay, later I will approve the rest. Okay, I have attached few questions. This one we had done. Okay, this one we had done just now. Settle. Try to proceed with this question for all three methods: graphical, bisection, and false position. Make sure you get the final answer in the range. Okay, so this one, the question asks you to find out the concentration of the dye in wastewater plant by using this equation. Okay, here it used C and P. Okay, do not panic if you don't find any Y or X. The equation can be any letters. Okay, so here it asks you to find the PHP. So the unknown here is the P, the one that you need to find out. As if P equals to X. Okay. For the dye concentration, C to reach 100 mg. Okay, C using bisection with initial gas of 3 and 5. Stopping criterion is 10%. Okay, so C, you replace the value of C in the equation to 100 and rearrange everything so that this side become 0. 0 this side. So 100 bring to this side. You have to rearrange the equation first. Okay, if you proceed with this current equation, your answer might be wrong. Okay, we must zero the y side first. Then, this is your XL. This is your XU. This is your ES. Okay, you must do the iteration until below 10%. Try to do this question using bisection. false position, and also graphical. Make sure you know all method, because in the midterm, I can't ask any of this. Okay, so this is the second question. This one's from previous midterm or final exam, I don't remember. Okay, next one is this. Okay, this one, it gives you straightforward equation. Range XL, XU. Stop until fifth iteration. Okay, here it gives you until fifth iteration. It doesn't give you the stopping criterion percentage. Okay. This one also try to do for the tree method, inclusive the graphical also. Bisection. And also false position. Okay, try all question using these three methods. Okay, this one, I think this one previous final exam also. Okay, here it gives you equation of gas diffusivity. M value given. Diffusing in a pore of nickel catalyst with diffusivity of 140. Okay, this one is D, 140. Temperature given 300, so replace the 300 over here. Predict the pore radius R. R here is the X that you need to find out. Okay, using FP until stopping criterion 0.5%. Okay, this one, it gives you the XL, XU. Okay, so this one also try to answer in those three methods as well. Okay, I want you to work in pairs. Don't work alone. Okay, at least 2 people. Answer all questions, or perhaps you can choose one. Then put your answer in here. Put your answer on the whiteboard. Okay, it's either you can directly write on here or write on paper, take picture, put the image over here. We will discuss in the next class, or I will review first. Okay, Ken? Please do this during the weekend, so that the next class we can straight away discuss.
Just start with X, or I have to mention it as consider equal X and then start with X.
Come again?
Because here is R not X. I just write, for example, I mean, for other come to like this A, B, C, for example, to don't be mixed with another. So can I just write, well, let's say R here, R equal X, and then start with X, and move to the capital. Is it possible, or must be start with the capital here? Because here is R.
Better to use this capital here. Okay, Ken. So please request through the link. I will approve the rest later. Try all these questions. Next class, we might discuss the answers, or I will need to proceed to the new topic, the open method. Okay. Okay, anything else before we stop the class?